All right, today we're going to work on chapter 3. Our x-intercept is where the line crosses the x-axis. Our y-intercept is where our line crosses the y-axis. This is standard form. Our rate of change, our equation for arithmetic sequence, and our equation for geometric sequence. Remember that a line that passes through the origin is called proportional. And a line that does not pass through 0, 0 is non-proportional. So what are some classifications if something is linear or nonlinear? Well, obviously, if our line is straight, it's linear. If our line has any sort of curve, it's nonlinear. Equations are the toughest. X equal to a number is linear. Y equal to a number is linear. Y equals a number times X, or even Y equals X are both linear. You can have your X and Y hugging numbers. Y could be alone. What makes it fail in equations? If it has powers, for example, Y equals X squared, that is not linear. If we have variables in the denominator, that is also nonlinear. And if you have variables hugging, that is also nonlinear. Find the x and y intercepts. Remember when we did this in chapter 3, it's where it landed on the x and the y axis. Our x-intercept would be at 14, 0. Notice that the other letter in our x and y intercept is always equal to 0. Our y-intercept is when x is 0 and our y in this case is 10,000. We can also look at them in a table. We want to look where 0 is. This is our y-intercept because x is 0, y is our number. And this would be our x-intercept because y is 0 when x is 4. You can also look at it as 4 is in the x column, so that's our x-intercept, and 248 is in the y column, which is our y-intercept. Find the rate of change, then write the equation. Remember, rate of change is just really our slope, which is rise over run. So if we can find our difference in our y's, which they are going up by 6 each time, and the difference in our x's for this case is going up by 1 each time, our slope or our rate of change is equal to y over x, or 6 over 1, or 6. In the second example, our y is going up by 76, and our x is going up by +2. So y over x is equal to 76 over 2, or 38 miles per hour. You could also use the slope formula, but we didn't learn that till later on. Determine if our graph is proportional or not. Remember, proportional has to go through 0, 0. Here, 0, 0. It does not go through 0, 0. Therefore, it is non-proportional. This graph goes through 0, so it's proportional. When we look at an equation, we're looking for what's adding to it. This would be +0, therefore it is proportional. Where this, our y-intercept is 5, therefore it is non-proportional. Next, determine if the equation is arithmetic or geometric. Find the next 3 terms in the sequence. So look at what's happening. It's going up by 2. Since it is plusing, that means it is arithmetic. Because arithmetic is plus or minus. Geometric is times, or what looks like divide, but we times by a fraction. Find the next 3 terms. If you keep adding 2, this would be 10, 12, and 14. This is +4. So that means our common difference is equal to 2. Our common difference is equal to 4. Our next 3 terms are 17, 21, and 25. Therefore, this is also an arithmetic sequence. This one's a little tricky. It changes signs, which is probably a little red flag to tell you that it's multiplication. It is timesing by -2. That is our ratio. And if we continue that, that is 40, -80, and 160. So this is a geometric sequence. And the last one, it's going down, but it looks like it's dividing by 3. Remember when we do our ratio, dividing by 3 is 1/3 because we have to write it as multiplication. So our next 3 terms would be -1, -1/3, and -1/9. And it's okay to do the decimal as well. And this is a geometric sequence. Write an equation for each arithmetic and geometric. Remember that when we do our arithmetic sequence, the formula for arithmetic is y equals mx plus b, where m is your common difference and b is your first term. When we do geometric, I'm going to squeeze this right here, geometric, we just did this. It's y equals a times b to the x, where a is your first term in your sequence and b is your ratio. So since these are the same problems from the page before, our common difference was 2, our common difference was 4, our ratio was -2, and our ratio was 1/3. Our equation would be f of x, or y equals our common difference, plus our first term. F of x equals 4 times x plus your first term. F of x or y equals our first term, -5, times our ratio of -2 to the x power. And finally, f of x or y equals, I know it's divide, but our first term is 27. And how do we write divide by 3 as multiplication? Multiply by 1/3 raised to the x. The last two screens is this linear or not? Okay, so linear, remember, straight lines are linear, equations are linear, with no powers, or just numbers, absolute value, any powers, denominator, square roots. Oop. And this one actually is, oop, my x is not going to cooperate. There we go. And then these are considered curved. Even though this is a straight line, it bends, so it is not linear. Did you get those right? Okay, arithmetic, geometric, or neither sequence. Checking these to make sure that they are correct. We have geometric, we have neither, and arithmetic. This is neither. Oh, it's just going to go on top. This one is arithmetic because it goes down by 5. This one's geometric because it's, oops, sorry, that's arithmetic. I just dragged the wrong one, sorry guys. And this one's geometric. I think I missed one. And this one is multiplying by -2, so that's geometric as well. Look in the completed notes. I have them all labeled correctly. Sorry about the error. And then lastly, how can you match these up? You need to look at the first term in the sequence and what it's going up by. So this is plusing 2. Therefore, this one matches it. This one starts with 9 and it's going down by 4. So the one that adds 9 and going down by 4 is this one. This one times by 5 and my first term is 1. This one starts at 20 and divides by 2, which we know looks like multiplying by 1/2. This one starts at -3 and goes up by 3. And the final one starts at 4 and times multiplies by 2, which is this one. All right, last one, proportional or not. Must go through the origin. Therefore, this is proportional. Proportional. Non-proportional. It does not go through. Non-proportional. Nothing's being added. Proportional. Added, subtracted, not proportional. Not proportional. 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 And not. So this is what makes it fail. These all would be adding 0. They also go through the origin. These do not go through the origin, so they're non-proportional. Be good for the sub. Remember, everything is in completed notes.